Let's move on to this concept of modulus, or what is also known as absolute value. Now when we say mod of x, what do we understand by that? Mod x or modulus refers to the magnitude of x. So when we say mod x, we actually are referring to the magnitude of x. Now one of the most common questions that we ask in class, what do you definitely know about mod x? And the most common answer is mod x will always be positive. That's incorrect, because mod x may not always be positive. Mod x will always be non-negative, because modulus or absolute value can be 0. So when you say mod x will always be positive, you are saying mod x or modulus can never be equal to 0, which is incorrect. Hence, what we definitely know about modulus or absolute value is that absolute value is always non-negative. Now how do we solve this further? So suppose we say mod x is equal to 4. Then what does it mean? It means that x is either equal to plus 4 or minus 4. So when we open up the modulus sign, then we are supposed to take both possibilities, positive and negative. However, we need to understand that mod x will be equal to x only when x is greater than or equal to 0, and mod x will be equal to minus x if x is less than 0. Very often this point is ignored, and hence there are errors when you calculate problems or when you solve problems. Let's take up some examples. Let's look at this example. Mod of x minus 4 plus 5 is equal to 12. So the first step in the solution would be mod of x minus 4 is equal to 7, which means x minus 4 is equal to 7, or x minus 4 is equal to minus 7. Now if you were to solve this further, we would get x is equal to 11 or x is equal to minus 3. So there are two possible values of x satisfying this equation. X can be either 11. If we put x equal to 11, the mod reduces to 7. 7 plus 5 is 12. Or x can be minus 3. If you put minus 3, then within the mod sign you have a minus 7. When you take the modulus of that, it becomes 7 plus 5 is equal to 12. So there are two solutions here. X can be either 11 or minus 3. If we move on to another example, now here the first step would be mod of x minus 4 is equal to minus 3. And if you think, we can now write mod, removing the mod sign, x minus 4 is equal to minus 3, or x minus 4 is equal to, when you take the negative part of it, we cannot even move beyond this point, because we have learned that modulus is always non-negative. So how can mod of x minus 4 be ever equal to minus 3? This is not possible. There is no solution, because this is incorrect. This is not possible. So when we are solving questions involving modulus, the way we would go about it, if I go back to this example, when you remove the mod sign, you're supposed to take positive as well as negative possibilities for whatever is there within the modulus sign. Let's try and look at another approach. Let's try and understand modulus slightly differently. When we say mod x, what we actually mean is distance of x from the origin. Now this is a graphical method of solving questions involving modulus. So when I say mod x is equal to 4, it means distance of x from the origin is equal to 4. Hence, if distance of x from the origin, which means from point 0, is 4, x can either be plus 4 or minus 4. Using this concept of distance from the origin, if we were to solve this question, we've already reached this stage, which is mod of x minus 4 is 7. So now if I say distance of x from 4, now since you have mod of x minus 4, this would refer to distance of x from 4. And if I say distance of x from 4 is 7, it means x can be 7 more than 4 or 7 less than 4. Now if x is 7 more than 4, that means x is 11, and if x is 7 less than 4, then it would mean x is minus 3. This can be understood very simply by looking at a number line, and if we plot the point 4. So when I look at distance of x from 4, which is equal to 7, x is 7 more than 4, which would make it 11, x is 7 less than 4, which would make it minus 3, and hence there are two possible solutions. Once again, the same two solutions, but we are trying to understand that in a much simpler fashion by using the number line. So the concept of modulus can also be understood as distance from a particular point. Mod x would mean distance of x from the origin. Mod x minus 4 would mean distance of x from 4. If it was given as mod of x plus 5, then it would mean distance of x from the point minus 5. We take the given distance and take it on either side of the reference point. So this is how we can solve questions involving modulus using the funda of distance from a reference point. Let's try and look at a few properties of mods. We have a few expressions here involving mods, and we need to look at each expression as a left hand side and a right hand side. So we need to connect these two by something in between. That something in between could be equal to, greater than, less than, so on and so forth. So when we look at an expression mod of x minus y versus an expression which says mod of y minus x, what can we say about these two expressions? If you use values, you will notice whatever be the value of x and whatever be the value of y, these two would always be equal. Similarly, when we look at these two expressions, you have mod of x multiplied by y, and that's split up as mod x multiplied by mod y. Once again, whatever be the value of x and y individually, these two would always be equal. However, the next two are not as simple. When I consider this particular example where you have mod of x plus y on the left hand side and split up as mod x plus mod y on the right hand side, these two will not always be equal. The most common answer, there are two kinds of answers that we get depending on the values taken or values considered. It is possible that these two are equal. It is also possible that this particular expression is less than this particular expression, and hence when we combine, this would get connected as mod of x plus y will always be either less than or equal to mod x plus mod y. If we consider both x and y as positive numbers, then these would always be equal. However, if we consider x as a positive number and y as a negative number, then this left hand side will always be less than the right hand side. So taking all possibilities into account, mod of x plus y will be less than or equal to mod x plus mod y. In fact, this is an approach that we should always remember when we are trying to solve questions using values. Never ever come to a conclusion based on one single value or one single set of values. We should always try and take multiple values and different possibilities, both positive, both negative, one positive, another negative, and so on. And also remember, 0 is also a value that can be used. Coming to the last one, when we look at mod of x minus y, on the right hand side split up as mod x minus mod y, this would always be greater than or equal to. And we have a similar logic for this. If both x and y are positive numbers, it would always be equal to. If x is positive and y is negative, then the left hand side would be greater than the right hand side. So when we are trying to look at these various possibilities, one very simple way of trying to solve such modulus based questions would be using values. But remember, as we've discussed here, never come to a conclusion based on one single set of values. Always take multiple sets and try out various possibilities in these multiple sets. So let's summarize by going back to our shopping example. We are in Granth and we are trying to buy books and CDs. The example that I had stated earlier, if I were to buy 7 books and 4 CDs, I would use up the entire amount that I have, which is 1500 rupees. Please remember, we've already learned, don't randomly take the variables as X and Y. Since we are buying books and CDs, use the variables as B and C. So our first equation would be 7B plus 4C is equal to 1500. If I reverse these numbers, suppose I were to buy 4 books and 7 CDs, then I fall short by 300. So the total amount that I would have to pay for 4 books and 7 CDs would be 1800. We had studied this kind of an example, would be an example of interchanged coefficients. And how do we solve such examples? We add and subtract and then worked with the 2 new equations which are simpler to use. But please note, we don't need to do anything of that sort here, because the question asked is not the value of B or the value of C. The question asked is, if I have to buy the same number of books and CDs, what is the largest possible number that I can buy with the given amount that I have, which is 1500. And the simplest way of solving this, let's just add the 2 equations. If we add the 2 equations, we get 11B plus 11C is equal to 3300, which can be simplified as B plus C is equal to 300. And now if I multiply this by 5, then I would have used up my 1500 rupees. So please don't blindly try to find the value of B and the value of C and then check what is asked. First check what is asked and solve accordingly. The solution here simply is, I can buy 5 books and 5 CDs in the money that I have, and that is the largest possible number of books and CDs, provided the number is equal, that I can buy with the given amount. So please remember, choose variables correctly, appropriately, check what is asked, and only according to that solve the equations. Very important for this chapter of equations, linear equations.